Alright, this is this gnarly piece of steel that I've got that we're going to make up the new table with. Now, I got this out of my father's estate, I guess. He had it in stock, along with a lot of other steel that I've got. I have no idea what this is used for. It's actually measuring up just over 51 mil, so it's pretty old. It's 2 inch. So it'll just make, if it cleans up, it'll be bang on size. So I'm hoping we've got a little bit of clean-up room on this. You can see I'm going to set up with my cut with my 9-inch grinder. I don't have any oxyacetylene, so it's going to have to be cut with the grinder. And then we've got a couple of small holes over here and here that need to be plugged and welded, but you won't see them when it's done. Alright, we'll get this stock cut out, so I'll see you when I'm set up ready for grinding. Alright, so we're back outside. It's been a couple of days since I put this lump of steel down here, but we're going to start cutting it out. So, the main weapon of destruction is going to be a 9-inch grinder. Now, these are basically banned in the industry now because of the danger of the things. I think the maximum we go to now is a 7-inch. So, I hate using it. You've just got to be so careful and look at your body position and where you're going with this. So, grinder. Having double hearing protection on, safety glasses, face shield and a helmet with a P2 dust mask. So we're going to tarp right up to do this. This is going to take some time to get through this 50mm, so let's make a start on it. Alright, first blade down. We're probably about halfway now, so we've gone through one blade. Just going to put the next blade in. When you are changing blades over, always unplug the things. You don't trust the switch, always unplug them. Alright, I'll get this changed out now and we'll get in for the last half. So far it's looking pretty straight. Not good for my arthritis though, I can tell you. It's killing me. Alright, we're through. Alright. A little bit off at an angle, but I've got plenty of meat left on here to clean up. Alright, I'll get in with the grinder and clear up all of these dags. Obviously something's been welded onto it over the time. Alright, it's starting to get dark. We're out of daylight savings now. So I'll pack it in. We'll deal with that grinding tomorrow night after work. Alright, we've got this slab of steel set up on the bridge port, and I've got my horizontal milling attachment set up. So the plan's going to be, I want to go minimum cleanup on all of this. It's mainly to get it squared up all the way around. And then we're going to give it a very light lick across the top and bottom. So it's all 6 sides are going to be trued up and squared. Then I'm going to rough out where the dovetails are,
I'm going to leave about 3mm all over on that. I want to try and minimise the amount that I clean up on these, and I want to try and keep the lengths as much as I possibly can. Alright, let's get set up and okay, that's the first side done. I'll rotate this around, then clock up that face, and then we'll start machining these edges here. And we'll work our way around until we get this squared up, and then we'll deck the top very, very lightly. All right, so just as an initial setup to get this squared, I just use my tri-square against a tenon block and get that squared up pretty close across there. So that gets me within a bull's roar. Then I can set up my dial indicator, and we'll clock that face then. That way we can be sure that we're we've got two sides that should be dead parallel with each other. So let's have a bit of a look. So that's measuring up at 278.93. 278.93. Alright, just got one more side to do. This is the side that we cut off with the cut-off disc on that 9-inch grinder. So just got to give that one a lick, and then we've got all four sides dead square to each other. And then we'll start with the deck. But something's happened on the back here. It's almost like a lamination has opened up, but when we flip that over, I'll show you what's happened. Bit of a pain. But we'll have I don't know if these are laminations or what they are, but these have opened up since I've cut. So I'm assuming it may be a lamination. I've got other smaller laminations around it as well. There's another one down there that you can see. I don't know how deep they're going to run, but that's on the edge roll. And it's been going through the mill, so there may be a small lap there. So my plan is to try and keep this as thick as we possibly can, but I don't want to have that floor in there, but here is to see. So as far as depth goes, at the moment, it goes in around about 4mm, and once again I want to try and keep the maximum amount of width that I can as well. So just have to play around with it a bit and try and get the best fit with what we've got here. Alright, we'll get set up. We're going to do the deck next. So I'll do this side first where we have this lamination, so I can pull it down on the other side nice and flat. Alright, let's get that set up in the mill. Right, so it's after a 0.15 cut, so a little bit heavy over this side, touching here, belly's out over here, touches here, so it's a bit all over the place. Anyway, I'm only going to take light cuts on this because of the vise setup I've got. I've never used these vices before. I got them off eBay very, very cheap, about $50 for the set. I've never tried them before, so far so good with them, but we'll just take our time until we can trust them. Well, you can see that sort of looks like a lamination or something is now starting to come out. It doesn't go any deeper than that. So it looks like a defect that was being rolled. I've marked it across here and across the back in the middle there as well. And even though the side hasn't been machined yet, it's all within 0.05 of a millimetre, so very happy with that. So I've got another couple of mil to go to get that cleaned out. But bearing in mind I want to try and keep this as thick as I possibly can. Alright, I've got set up for the other side now. That first side came up really nice. Came up beautiful. I'm using these little button clamps up against the side, so these actually push in at the same time they pull the part down, and they bite in quite hard. These are hardened teeth on these. I always put strap clamps behind them because you're only relying on this little cap screw to lock it into place, and they will try and pull back when you do pull them down. So if you are using, put a strap clamp in behind them. Well, we're going to take about 1/4 of a mil off the top, and we'll see how that goes. Righto, so that's the deck, the top decked off now, and that's come out quite nice. I'm going to put my little fly cutter over this. I'm just going to take maybe 1/10 thou off over the top, 0.2 of a mil, and I want to see what sort of finish I can get. So we'll get that fired up. Right, we've got that clamp down now. We've got little finger clamps here and our straps behind them. I've only just marked out, it's only a rough cut out for the stress relieving. I've left around about 4mm all over on this. So hopefully we don't get too much movement and it will clean up quite comfortably. Alright, let's get in to start roughing this out. I've got to go 18mm deep on this. That leaves me again 4mm to finish out. Oh, it's going like a stuck pig, isn't it? Right. Bits and pieces falling off the mill here. Jeez, that's vibrating like crazy. Let's try and drop the cut depth back a bit. Alright, as you can see, I've changed the clamping arrangement. I've got rid of the little finger clamps that were down here and put on some strap clamps. I'll rough out that width and then I'll move the whole thing over and then I can bring it out to final width out here. So I have to do that in 2 setups. But yeah, just a cheap eBay cutter. I tell you what, I'm not real impressed with those tips either. So I might have to invest in something a little bit better. Anyone's got any recommendations on a 50mm shoulder shell mill inserts, let me know. Alright, we'll keep going, but what I've also done is I've had to put it into low gear and increase the chip load on the tooth as well, and that's really cut down the vibration. So reasonably thick chips coming off there. But Bridgeport's obviously not the greatest in rigidity. Well, I might even just pull that back a little bit too. Got a little bit more rigidity into the ram there too. It's sitting out a fair ways. I could try and get that back a bit and just. What a difference pulling the ram back made. So it came back in another 120mm and yeah, it just made a difference in the rigidity. So that was another 2mm cut, much smoother. Okay, that's roughed out to depth. I've got to take another bite at it, so I've got to move it across to pick up that line there, and we'll cut that down 18mm. Before I do, I'm just going to set up an end mill. I'm just going to clean up that raggy edge. So I'll set up and do that now, and then we'll get it moved across, ready for the last cut. Shouldn't take as long this last cut. I can do that in one run. Alright, so that's our roughing out done for the dovetail section. Yeah, I've got to look at how we're going to heat treat this now. I'll put a bit of a plan together and see how we're going to do it. I'm going to get cleaned up here and bring you back and see how it all came out. Alright, I've got this sitting on top of this slideways, actually up on top of the tapers. So it's not sitting down on the main bearing surface here, obviously, because we haven't machined the dovetails in yet. Give you a bit of an idea of the height difference between the two. This is the old cast iron table. You can see the difference there straight away, and on top of this table it also had that big rotary plate that sat on top of it, and that was another 50 millimeters thick. So you can sort of see I'm gaining probably around about 70-80 millimeters of extra room underneath the ram by making up my own table. Now, there is a flaw in the design. Well, I see there's a flaw in the design on this particular table. If we have a look at the size of this gib, it is very, very wide. It's actually wider than the actual bearing area, and that does not contact the bearing area either. That is pulled up hard up against the underside. So this is upside down at the moment, and that has caused an issue on this table. And let's have a look at that. I'll get this down out of the way. Now, because we have such a very small bearing area on that edge, that is actually worn in there. It's about 2,000, as best as I can measure it, it's about 2/1000 of an inch. You can actually see the wear mark that's in there. Now, when I put my surface gauge on here with my test dial indicator and run that up and down, I get around about a 2/10 of a thou difference between the top and the bottom, and that's consistent all the way along. Same on this side, and the difference between the two is negligible. So it's still very, very accurate from that point of view, but it does have this wear issue here. So in my design, I'm going to increase that wear area, or that bearing area, considerably. That existing arrangement actually sat about 3 or 4 millimeters in. You can actually see the line where it rubbed. So I'm going to make mine skirt flush with the edge or just over. That's also going to stop stuff getting down into the slideway as well. I'm also going to change the gib design. That had a very, very wide gib that had no bearing at all on the table. So I'm going to change the gib design and increase the bearing area on here considerably. So that should give us a much, much more robust arrangement. Now, given the fact that, you know, maybe 60, 70 years of time has gone past, and that's, I guess that would be considered fair wear and tear. But I think we can do something better than that. The other option is to machine the entire lot back, machine it back over here, or just machine it back here and have a difference in the heights. But for what I'm doing, what this machine is going to do, I think we can increase that bearing area and get that accuracy back. Alright, so we are going to heat treat this, or I have a go at heat treating it. So normally you'd send it off to an organisation, a heat treat company, and they would stick it in their furnace, soak it at 640 degrees, bring it up to temperature, and soak it for 2 hours per 25 millimeters of plate thickness, and then let it cool out in the furnace. So I don't have that facility, obviously, so we're going to try and make a furnace to do that job for us. And look, we'll see how we go. Alright, so the next time you see us, we'll be hopefully setting up a brick furnace for this to go into. Brick-wise, I've got a heap of these bricks here, 2100 bricks, or 2100 degrees Fahrenheit bricks, and I've got some fire bricks as well. So I think between all of that, and I've also got some Fiberfrax insulation as well that we can put on the inside. So we'll see how we go there. Oh, and listen, while I'm here, one of the wheels we cast up in the foundry, so that was for an R-Class loco actually. It's a spare that was left over. But yeah, that was a pretty good quality casting, that one. Left it as it is and one hanging up on the wall. Anyway, that's the bricks we're going to use. And that's the big slug of metal we're going to put inside, and let's see how we go.